Essentially what we're going to do is see a large industry. We're going to see how it operates in relation. I'm not sure whether the plant will be operating, and sometimes it's an advantage if it isn't as far as seeing things. And we'll see operational components, and we'll also see rehab components. And if you had a chance to scan that handout, this quarry has been in existence since the early 1960s. In fact, it was one of the key reasons the Niagara Escarpment Commission was formed, because it was a different owner in the early 60s that decided it would be a good idea to blast out part of the Niagara Escarpment. Obviously there was a big public outcry. People said, what's going on here? And that was one of the reasons we have the Niagara Escarpment Act, to ensure that that type of devastation didn't take place. You're going to see rehab in terms of different philosophies over a number of decades, one from a safety type recreational, one in terms of a forest, traditional deciduous coniferous nitrogen fixer type development, on to something called landscape replication or quiesta, small escarpment type things on the perimeter, water management principles, and they also developed a wetlands. And so the nice thing about this site is that you see a full range of different rehab technologies, magnitude of the industry, etc. So hopefully enjoy the excursion. And I'd like to introduce Jessica. She's going to be our tour guide today. And
Hi everybody.
Hi Jessica.
Okay, welcome to the Milton Quarry. We're going to stay on the bus for most of the duration of the tour because you don't all have the PPE. Well, I see one person has a hard hat, but anyways, but while we have the opportunity, I'm going to go ahead and get you off the bus and just introduce you to the quarry and show you a couple of our products. So if you can just sort of follow me. I work for a company called Holcim, and we own Dufferin Aggregates, which obviously owns this quarry. We also own Dufferin Concrete. We operate the Mississauga Cement Plant and another one in Quebec. And we own Dufferin Construction, so we build things like the 407 ETR, roads, bridges, foundations, etc. Dufferin Aggregates in particular operates about 14 different pits and quarries around the GTA in Southern Ontario. And these are some of the major products that we make. Do you guys know the difference between a pit and quarry?
Yes.
Okay.
We better.
Couple of things. Obviously you guys are environmental technology students, so you would have heard a bit about pits and quarries. What are sort of some of the negative things that you heard about quarry operations? I'm going to change your mind about all of them today. Anybody? Dust and noise, obviously major environmental impacts. Rehabilitation. Very changed over the years, the requirements for rehabilitating a quarry, and they're still changing. We're required to set out a rehabilitation plan before we dig, before we remove any trees, before we do anything. We have to have a life cycle assessment of our quarry completed. And so today you're going to see what an active quarry looks like and what a quarry looks like when we're all done with it. So those are the major ones. There's one other one that I hadn't said yet.
You're destroying the land.
Okay, well I'm going to change your opinion about that. That's okay. Perfect. So the other major environmental impact is water. We have to de-water in the quarry because obviously we're extracting below the water table. If we stopped dewatering, it would fill up and become a lake. Because the groundwater isn't going above the surface of where we are actively extracting. So obviously when you're dewatering below the groundwater surface, you have a potential to impact your neighbors. And we have a really sophisticated system at this quarry. It's quite unique. And I'm going to talk about it more sort of when we get up there. So these are the major environmental impacts of a quarry, and they actually, a lot of quarries didn't really have to do a lot to mitigate their impact, say in the 50s, 60s, 70s. There wasn't a lot of restrictions in regards to where they could extract the stone, and these are things that have really changed over the years, and I'm going to show you a lot of what we do here to mitigate our impact, to be a good neighbor, and to reclaim the land before we leave. So I'll address those sort of as we go through the quarry, and hopefully you guys can learn a bit about responsible quarry management. one good example of that, if you look behind you, see that bridge there? Can anyone tell me what this feature is? Niagara Escarpment, right? So it's a UNESCO World Heritage Site, and the Bruce Trail actually runs through our property for 3 kilometers. We have an agreement with them. One of the reasons we made that agreement was because back in the 60s, when there wasn't a lot of restriction on where you could extract, we made that big, ugly hole in the escarpment. Not very nice, right? We would never do that today. But there wasn't as much concern about these things back then. So what we did, obviously non-renewable resource, we can't put it back. We made that bridge so that people could see the quarry and look out. You can see all the way when you go up there to Toronto, and on a clear day you can see the CN Tower. So as I say, the Bruce Trail goes right through there, and you guys are free to come whenever you want and take through the quarry. We also have partnerships with Conservation Holcim. We're donating 1,000 acres to Conservation Holcim when the life cycle of this quarry is finished. We have to get approval from a lot of regulatory bodies to operate this quarry, and actually any quarry. That includes Ministry of Natural Resources, Ministry of Environment for this particular site, Niagara Escarpment Commission. We also have to liaison with the upper tier and lower tier municipalities. So there's a lot of people that we have to please in order to operate this quarry, as well as just our surrounding neighborhoods and action support groups and stuff like that. People say like, okay, well, why don't you put the quarries like far away from homes and all this stuff? Well, we have to transport all of this heavy rock. Our customers have to drive in here and get the rock from the quarry and then bring it back to their construction site. So you can do that in about half an hour from Toronto to get here. It wouldn't make much sense if they had to drive a couple hours to do that, right? So in addition to that, your environmental impact from operating all those trucks and delivering the stone would be a lot more if you were further away from the GTA. So we have to find a way to operate the quarry in populated neighborhoods and actually mitigate our impact and be a good neighbor. To give you guys a little bit of an idea of my background, I took a similar course to what you guys are taking, environmental technology. I took it at Georgian College, and then I went on to do a degree in geoscience at Brock University. So I'm fairly new to the company. I've only worked in the company for about a year, and I started off doing environmental compliance in our concrete sister business unit, and I started in the aggregate sector about 4 months ago. So that's sort of my background. And obviously, like, you know, keep in mind that I took the same course you guys are taking. So we do hire people that from your guys' background. We have a QC person that's going to talk to you later on in the tour about, as I mentioned, how we meet the spec for these products, and she took environmental technology as well. So yeah, it's pertinent to prospective careers for you guys, possibly.
So is this an example of like what you get from the cliff?
Yes. This is what we would call an armor stone. So it's a big chunky rock, probably not appropriate to go into a primary crusher. We sell them to like landscapers and stuff like that. We do have a total of 18 different products that come directly out of this quarry, and those range in size, shape, specification. But yeah, we place these rocks sort of all over for landscaping purposes and then sell them to different landscapers. But
If you had to guess how many trucks were going to come in and go out today,
maybe we just saw, I don't know.
20 in 5 minutes.
Yeah.
So it's a pretty good.
I mean, it really varies day to day. I've been here on days where you don't see very many trucks, but obviously there's a job going on or a couple jobs going on, and people are coming in and out. Just to tell you guys, those aren't our trucks; those are our customers, right? So there, yeah. I mean, it's going to vary day to day. That truck there, it's called it has a conveyor. It's called a live bottom feed. It has a conveyor on the bottom of it. It's kind of interesting. We actually see that more commonly now than your old-fashioned dump truck, because it obviously doesn't have to lift the bucket, and it's a lot safer, especially if you're doing an uneven road surface or on a hill or something like that. It doesn't have the potential to tip over or lose its balance. So there's a conveyor running on the bottom of the truck, and it just opens up the back and conveys all the stone out. It's kind of a relatively past decade type of thing. They've been using those a lot more. The average truck is about 35 tons. We have a capacity to do 2,000 tons an hour. So that's, we don't reach that. When we were building the ETR, we were almost up there. So that's how much.
So my name is Melanie. My job here is to test the products, like Jessica said. So each product here has its own specification for the sizes of stone. So like Jessica was saying, that the concrete is made up of stone, sand, cement, and water. So for our stone here, it needs to have big stones to hold together, and then little stones to fill the voids. So I do gradations. I run the stones through a series of sieves and take percentages of each size, and see if they meet the specifications. So I test the material right from the face of the products. You'll see the shipping faces when you go up into the quarry, and take it right where the trucks are loading, so it is representative of what's going out the gate. I also, when the plant's running, take the material right off the belt so we can monitor it as it's being produced. I think you're asking about how many tons are shipped here. I know that this year we produced about 3 million tons. So by the end of the winter, which is about March, most of that will be gone. Percent crushed here is 100% crushed based limestone. Out of our sand and gravel pits, it has to be at least 60% crushed. You have the round stones, like what Jessica was saying about being able to bind together. It doesn't work as well when it's round stone. So the crushed is a big part of it. We have to monitor that too.
One of the important things is the fractured edges. What's the percent fractured edges like for concrete stone and stuff?
Well, that's the crushed. For concrete stone, it has to be at least 60% crushed. And obviously here it's very good quality stone because it's 100% crushed. Here at Melton, my lab is called a C lab, so I focus mainly on gradations, washes, a couple other things. We have a D lab. Did you talk about the D lab?
No.
We have a D lab for Dufferin Aggregates, actually for Holcim now, and they do a series of more, there's a lot more tests that they do on the aggregates, and they'll do them not as frequently as we do them, and that tests stability of the stones. So one of the tests is they'll hit it with a whole bunch of ball bearings to see how well it holds up, or they'll put it through a series of freezing and thawing to it represents what it would do when it's in the road. So and as far as quality of stone here, it's a very good quality in that respect.
They also make columns like this and test the strength of it, how much pressure we need to crush that. So it's kind of a fun little lab. Fire stuff at it and break it and see how strong it is. So, but yeah, the fractured edge is an analogy that QC often goes through that helps me understand why we have to crush stone. If you think of a jar of marbles. I could put my hand to the bottom of a jar of marbles, and that's because all of the marbles move past each other and shift around, right?
They're all the same.
They're all round and they're all the same size. Whereas if you have jagged edges, I wouldn't be able to do that, right? Because they would all sort of fit together. So it increases the strength. So when you take that analogy and transfer it to something like a road, when it freezes and thaws, if all the stones looked like the pea stone there, they would shift around, and you would have more fracture propagation and things like that in your road. So it's sort of an analogy to understand why it's so regulated that we have all these fractured edges.
So what's the protocol when the product doesn't meet?
If it is a production issue, so if I took a production sample and it didn't meet the specification, there's usually something we can do in the plant. So that's, it doesn't happen as often with the shipping because I've tested it when it was being produced. So usually there's something we can do in the plant. There might be a hole in the screen. We might have to tighten up one of the crushers. There might be like water that's turned off or on, like too much, too little. There's different settings we can play around with to try and keep it consistent.
Are those your standards, or are they set out that you follow?
Most of the products here have MTO standards that everyone like across Ontario follows. Some of them have CSA standards. We don't do too much of the CSA testing here.
Sorry, what?
CSA, Canadian Standards Association. Yeah, so it's not, there's some, we have our internal targets that we keep like a closer band so that we don't have as much variability. It can be within specification, but one day it might be too coarse, one day it might be too fine. Still in spec, but it's variable. So it doesn't help our customers either when they're getting a load of fine concrete stone and then coarse concrete stone. It doesn't, so we try to keep it within our internal targets.
See, potentially what happens, not so much with the concrete stone, but with a crusher run where the blended material is, when it comes out of the stacker and falls, you can get some segregation. And that some clients quibble about some of the products sometimes. It's difficult to avoid in terms of that segregation, because if there's a pile here and it's falling off a stacker, and obviously there's some change in its mixture, and you take a loader and dump it in the truck, that doesn't represent necessarily what Melanie did as a sample that came off the bed.
And in addition to that, I mean, we test the stone here before it goes out, but then most often our clients are also testing the stone at the job site. And we ensure that they have people testing their stone that know how to take a proper sample from a pile. So like maybe talk about how to take this proper sample from a pile. Right?
Taking from the pile, I have a loader operator take several buckets from across the face. So like what you were saying about segregation, you're going to have more of the coarse material on the outside. So we'll have him take material from here, like all the way across, and then mix it up for me. And then I'll take a sample across, like diagonally across the face randomly, so that it's representative of the whole.
Whereas we run into conflict sometimes with our customers. It's something that the aggregate industry has to battle with, is the testing on site. If they just walk up to a pile, it's been sitting there for 2 days, and take a shovel with it, well, that's not going to pass.
It might have been rained on, it might have been...
Exactly, so there's a lot of things that can make the pile segregate. So,
and the other one is that another variability for the aggregate sector is there are nuances regionally. So for instance, as you know, there's an envelope in terms of specifications. Some areas may have for years had one part of the envelope or the bottom end of the envelope, and then automatically if they get a product that's at the top end of that envelope, they'll say, well, this product is no good, but it still fits the MTO envelope. So there are local nuances. It's like the color piece that you mentioned. If you send a product that's the wrong color, it can meet all the other specs and they just don't want it.
We don't have any product here that we can't use or sell anywhere. There's no pure waste products. Even the fines that come off the stone, we wash it. You'll see that system when we get up there, but that's a closed loop system, so the fines will all go to a series of settling ponds. We clean those out once a year, and we keep that material and use it in our rehab area, because it is native material, and it works actually quite well for infill soil in our rehab area. So we do use everything that comes out of the ground.
I took environmental in Georgia College, and I spent a couple of co-ops doing QC, so learning about the aggregates and sand gravel, and then I came here. I've been here for 5 years.
It's a really big company. It actually depends what time of day you check over who's bigger, Lafarge or Holcim. So we're pretty much on par with them for biggest cement company in the world. So as I say, it's based out of Switzerland, but we're operating in over 77 countries. In over 177 countries. And we have over 85,000 employees worldwide. So it is quite a...
So if you wanted to work in Switzerland, could you move to Switzerland? Maybe?
If they would have me, I might be able to work there. We do annual environmental reporting, and we have internal company targets that we have to meet for sales, environmental compliance, everything. And so we have to give annual reports to Switzerland all the time.
Hole underneath.
we just drove under was our scale house. Every truck that comes in here is weighed on their way in, and then we weigh them again on their way out. That's because we get paid for the weight of aggregate that they take out. We have a system over there. It's similar to like when you go to Costco and they put those things in the pipes that shoot up. We have that for safety reasons so that none of our truck drivers need to actually exit their vehicle. We have a policy, we don't want them exiting their vehicle at all while they're on the site, and that's for safety reasons. In addition to that, on their way out, we'll pass by it again. It's on the other side of this mound. All of their tires are washed before they leave the property. So they have to line up and go through a tire wash station. Obviously that's for dust mitigation. Okay, and this is our processing plant. This is where we make all of our products. It starts behind me at this conveyor where it goes to a primary crusher. So obviously we blast the stone. We haul it in 777 trucks, which can haul up to 100 tons of raw stone, and it goes to a primary crusher. You can't see the primary crusher because it's underground. Again, dust mitigation, noise mitigation creates a lot less dust and noise if it's underground. It's what's called a jaw crusher. It looks like a jaw. It's basically doing this. And then we have an operator with a drill arm who's sort of assisting the rock getting into the crusher. That stone falls underground and travels through a conveyor to a surge pile. Our surge pile has been lowered right now. It's not very big. But essentially from the primary crusher you get about that's 25 centimeter diameter stone around this big. Okay, from that surge pile sits on top of another conveyor which is underground, so the whole plant is really gravity fed, and those stones will trickle down to that underground conveyor and go to what we call our secondary crushers. Those will crush the stone into various sizes that then go to a series of screens. So this whole building is filled with screens. It's like a sorting bank. Like they're all different sizes, and they just sort the stone into all the different gradations, and then we can mix them into our various products.
Like a trap door that allows product to come out the bottom? Is that what happens?
Yeah, and there's actually a conveyor running. I don't know if you can see it. It's sort of where that red bar is. There's a conveyor running there, and then another conveyor running back where it would go. Our wash plant is back there.
Oh, okay.
And that's what washes the products. And then essentially it's more environmentally realistic rather than hauling every product to the pile to deliver the various products via conveyor. So we have conveyors that we can move around the different piles and stack the various products in their piles. A couple other things we do for mitigation on the site that you can sort of be aware of as we drive around are we put berms around the entire site. That's obviously, again, noise. Noise is going to bounce off the berm same way anything else would, and dust mitigation. This whole processing plant used to be located where we parked at the beginning of the tour. We moved it up here in the 70s to be closer to our product, but also to sort of move it away from the road. You can't really see the processing plant that well from the road, and we're a little bit further away from our neighbors at this location. Yeah.
How large is the entire site, and then just the site that you actually take from, like this site here?
Okay, well,
Roughly.
This area is called our main quarry. It's already been extracted, and the quarry that we're going to see that's active is called our North Quarry. I'm not sure of the individual parcels. I know the entire Milton Quarry is 770 hectares. Of that, 450 hectares will be extracted. So you can think of sort of the buffer around where that would be. We have 2 new cells that we have licensed that we haven't gone into yet. We haven't removed the overburden yet, and we're still doing monitoring for. But essentially we have about 15 years left at this quarry, give or take, depending on customer demand. We have our own mechanics at the plant to service all of our trucks. So we have a bunch of mechanics, fleet, we have the loader operators, we have the QC people, and then we have the people in the scale house, which work there with obviously the haul truck drivers coming in and out to buy our products. Hire for a 777 truck costs $20,000. Yeah, we do get complaints from time to time, and you know, we have a standard procedure for responding to those. We go out usually to the residents, and we also hold what we call community action plan meetings once every 2 months or so. We invite all of the local residents to sort of air their grievances, discuss what we can do better, things like that. We try to limit our blasting. We monitor our blasting. We have seismometers and things like that in the surrounding areas at our closest proximity to neighbors that monitor the blasting, and then that's actually required. We can't exceed a certain threshold for noise and vibration. In all reality, like I've seen a blast, and I was surprised at actually how quiet it was.
Yeah, it's disappointing. It is.
It's they're engineered to not be so loud, and also it's a very scientific process how we blast. I'll talk about it more when we're in the quarry, when you can actually look at the blast surface. So that's the primary crusher right there, that covered building, and you can see that there's a little it's sort of a drill arm, and there's a little window there. So there's someone that sits there when it's in operation. The 777s come and haul the raw stone and dump into that area, and then he operates that arm, and it has a drill on the end of it so that he can break the stone into smaller pieces so that it can get into the jaw crusher. So he sits in that little window all day. It's kind of cool to watch.
All night.
So this side of the bus, this is all our spent resources, and this has been rehabbed. And our rehabilitation area that you'll see at the end of the tour is actually located a bit further over there. So we have a wetland and a constructed lake over here. Okay, so we're coming up to our man-made reservoir. Do you guys think it looks really natural or nice? It's crystal blue water, right? Okay, this is not rehab. This is an active component of our quarry. We dewater the groundwater from our active quarry into this reservoir, and we discharge this to 2 tributaries and a provincially significant wetland to the west of the quarry. We have a full-time hydrogeologist on site that monitors the quality and quantity of water in this reservoir, and also monitors how much we're discharging to those tributaries. He's a third-party full-time consultant that we have on site.
How deep is that?
It is it's about 8 meters deep, and it's about 70 hectares of surface area. And the reason that we haven't bothered rehabilitating it is because we actually don't want an active lake here. We don't really want fish and algae and things like that in the water, because we are discharging it to those tributaries. You can probably just sit here for a second. In addition to that, we have a series of injection wells that line our active quarry. So an injection well is essentially the opposite of a normal well. Instead of pulling water out of the ground, you're pumping water into the ground. That's to replenish our neighbors' wells. So we have to be very diligent. Obviously, if someone eventually is going to drink this water, if it's going to go back into the ground, we have to monitor it. That's why there's someone here full time. So there's over 300 wells on this property. And I think there's over 100 injection wells. And as I say, they surround the perimeter of the quarry. He monitors all of those wells, and he works out of the pump house that's over down here that we're going to pass in a bit. And he basically, he monitors groundwater levels to make sure that, as I say, all of our neighbors' water, and we're not having an impact on the outside water table. So the reason we don't want algae and fish and things like that, I mean fish poo, right? So we don't want fish poo in the water if we're pumping it back into the ground, things like that. We have to keep the water clean. It has to be representative of the background criteria for the groundwater in this region. Yeah, you had a question?
Then how do you keep algae out of this water? You don't want algae.
Well, you just don't build a habitat for it. I mean, you can see the straight slopes that drop off. Well, you can see it better when we're on the other side. This side of the quarry has a very straight face. So it's all deep, which means that there's no habitat for smaller fish. Essentially, if you want to build a habitat in a food chain, you have to build a variability in depth and in ground cover and in the plant fauna and species that are growing there. So there's actually not a lot of habitat here. I mean, we do get the occasional fish, yeah, but not very much, because there's no smaller animals for them to eat, because there's no smaller habitat. It's all very deep. This is kind of like back in the day, you would have maybe rehabilitated a quarry by letting it become a lake and putting a standard slope in. It used to be, I think, a 4-to-1 slope. So you'd have a straight slope all the way around and it would look very constructed. Well, those habitats aren't thriving for animals because you don't have variability, you don't have biodiversity, because you haven't created multiple different areas for animals to live. A big fish likes deep water, but a big fish doesn't like deep water if there's nothing to eat, right? Same with algae. I mean, you get a bit of growth. We get a bit of algae on the shoreline and stuff like that, but not very much.
Put it in two terms, right? One in terms of surface water support that happens off-site in reference to the tributary concept that Jessica mentioned, but also in terms of groundwater regime. And also, if it helps you in terms of the lake, you notice Jessica's calling it a reservoir. And so if the natural system, the closest would be an oligotrophic lake. But again, in terms of the nature of the turnaround, and also remember the source. What's the source of this water? There's rainwater as well as probably groundwater, right, in those two things. So if we could just go back a step, how does this water get here?
Well, we have a sump pump in our quarry. So naturally, this area, obviously, this has been quarried. Resources have been spent in this area. So at one point, this would have been dewatered. When I say dewater, that means a sump pump at a lower elevation than our quarry floor that's pumping the water from the quarry floor. So you naturally have, I mean, you have a water table. You naturally have groundwater flowing through rock. It just happens very slowly, right? So we have a sump pump in our North Quarry, which is the next place that we'll make a stop. It pumps all the water that would naturally fill up that quarry, and it puts it here. In addition to that, you have groundwater flow coming into here, and that's what creates this whole lake. And then obviously precipitation, things like that. But that's where the water is coming from. And as I said before, if we didn't pump the water out of the North Quarry, it would slowly just fill up with water. Because you're naturally going to have it. On most days, I mean, you can look at the rock and you can kind of even see a little bit of seepage out of the rock, of the groundwater. But yeah, that's essentially what we have to do to be able to operate the quarry, which is significantly below the water table.
So let me just do one thing before you do that,
Yeah.
Tara. So there are two components. One is in terms of operational support of the plant and the process here in relation to access to resource as well as managing it for washing, etc. And then there are two other elements. One is groundwater support surrounding the perimeter of the property and surface water support. Mm-hmm. So hence, and obviously this serves, what we saw in terms of the metaphor would be when we looked at the primary crusher, they had something called a surge pile. Surge piles separate from the secondary plant. The reason they do the surge pile is they can shut one plant down and keep the other one operating. Mm-hmm. So this is in support of the same concept, right? It's a two-level concept.
So it helps us mitigate our impact to our neighbors, and we're acting as, I mean, in drought conditions or if there was an issue with water balance in the provincially significant wetland, we can replenish that, so we have that ability. But also we need somewhere to put all the water that we're pumping out of the North Quarry. So it is a very important working component of our quarry, which is why it doesn't look like a nice rehab. This is not rehab. That's why it doesn't look like a rehabilitated lake. It's a reservoir. It's a working component. Yeah.
Sorry, Tara, go ahead.
Yeah, there's a lot of activity going on here. What's the quality of this water like? Do you have to treat it before discharging, or is it fairly clean?
The water is fairly clean, yeah. We wouldn't discharge it if it didn't meet quality spec, and it has to meet background criteria for the groundwater in the area. So we test the groundwater and we test this water.
Right. So, but it doesn't pick up a lot of contamination from.
No, well,
You've got lots of trucks running in and out, so they're obviously dropping God knows what, and then that could be picked up in the dust.
well, the only issue that that might be of concern would be total suspended solids and pH, because you have an alkaline material.
Yeah.
The size of this reservoir allows total suspended solids to settle to the bottom, and there's actually, obviously there's dust on site, so you're going to have dust entering the water, but we position our intake to pump out at such a point where it is protected from that, and as I say, we do test those parameters to ensure that they're representative of the groundwater that's currently in this region. So we just have to do our due diligence about keeping an eye on those factors. You look at the size of the reservoir. I mean, the surface water in this reservoir is very clean. Another thing we have to monitor is temperature, which I didn't mention. When you're discharging to tributaries, they're naturally groundwater fed tributaries, and groundwater has a very specific temperature range. Things like brown trout will be very sensitive to that temperature range, so you have to make sure that they want a cold water stream, so you have to make sure that the water is cold enough. So we have to take a sufficient depth, but we can't take it too deep. So as they say, this is about 8 meters deep, so there is quite a bit of water there. I have the amount. Let me pull out my notes again.
Do you have an established contingency plan in case there is a spill? Say, if a truck does overturn
Or
and
drives
there's
into
a
the
major
reservoir.
spill, yeah.
Yes, yes. And you'll see on this side there is berms, so that, I mean, if a truck were to overturn, it's likely going to be a rock truck. Right? There's not, we don't have fuel trucks that drive around this quarry area. We have our maintenance trucks and we have our rock trucks. But yes, we do have a spill contingency plan in place, and everyone on the site has to be trained in that annually. So,
Cool.
Yeah, we do have a plan on that. And as I say, our hydrogeologist having him here 24/7, that's quite rare for a quarry. And I mean, he literally, his office looks out at this reservoir. So he can really keep a close eye on what's going on here. We have to do annual reports to the MOE on our water management system here. All of our testing gets reported to them, as well as groundwater levels over the years and over the current year, so historic and background criteria as well. And our consultant helps us write that report to the Ministry of Environment. So to answer your question, yes, they do monitor very closely what we're doing here.
Let's say the quarry's depleted in 15 years. I'll just make up a number. When we look out here and we come back 15 years later, what will we see?
If the quarry's depleted, well, it's a little bit up to Conservation Halton, because we're donating this land to them, and because it is beneficial in the sense that it can replenish the provincially significant wetland. It will be up to them whether, I mean, they're a conservation authority and they have a history in water management, so it will be up to them what to use this particular reservoir as. But I see it being a little more greened. I see it being a little more rehabilitated before we leave. We started the rehab that you'll see at the end of the tour. We started that in, I think, about 1990. So it's been about 20 years, and you'll see that the tree growth has, I mean, the faster growing species have sprouted up, but the coniferous trees are still quite young. But what we do is we progressively rehabilitate. So we start in one cell of the quarry, and as we deplete that and move into the next cell, we start our rehabilitation. So it's a progressive system. So right now we have a rehabilitated area of the quarry, we have an active reservoir, we have an active quarry, and then we have our reserve lands that haven't been touched yet.
It's a hard question to answer because obviously each one's specific to a site plan and what history there was to begin with. You haven't seen it yet, and we'll see it towards the end of the tour, but there's a wetland that that's further in that direction, and it's quite significant, it's quite large. So that's part of the progressive piece that Jessica's getting at in relation to rehab. But the other one, and Jessica may speak to it later, is the slopes you see across there, and the fact that they left some exposed. And part of this, in terms of the perplexing part of the rehab game, is when I worked for Lafarge, and we asked M&R, etc., about doing things like that, the Questa with landscape replication that looks more natural in terms of an escarpment function. Up until probably 8 or 10 years ago, they said no, because it was an inherent safety issue. And we said, come on, this is an escarpment. We're not trying to dodge the cost of rehab. We're trying to make the landscape look much more natural in terms of when we leave, as opposed to what Jessica's already made reference to in terms of the reservoir. You want a reservoir? Yeah. You want a non-functioning water body? We can do that, and it's cheaper. And it took a long time for regulators to get their head around the idea of having what real targets were, what we really wanted as an end use. And there's still a bit of a battle in terms of regulatory groups and their attitudes towards those. And it's understandable, right? And much of this landscape replication had been done in the UK for years. And that was part of the case that we were able to do it in Ontario. But for many, many years, what you're seeing in terms of slope landscape replication, and you'll see it later on in the tour associated with the wetland, it looks very, very natural. If you take out the quarry component, it's fine. So it's a tough one.
As I said before, you used to just have a 4-to-1 slope. Now the idea is that quarry rehabilitation is going to be catered to the site you're at, and it's going to be catered to what the surrounding landscape looks like. So when you look at the Niagara Escarpment, you see something similar to this, an outcrop of rock and a talus slope leading up to the rock. Mother Nature will naturally create that talus slope as freeze-thaw cycles happen and sediments and dead trees are dropped to the bottom of the slope. We just speed it up. So we're coming up here on the pump house. This is where our hydrogeologist stays all the time, except when he's out at the actual wells.
How long did it take to fill that up?
What's that?
How long did it take to fill that up?
I have no clue. I'm not sure. I imagine quite a while. The pump in that pump house has the power to do 150 liters per second. Yeah, no, we don't want that.
Make for good video though.
I'll make up a nice video here, Joe.
Okay, so you see how there's enough room for you to turn around when we leave, but you can just pull over here and turn it off again. And then when we leave, you're just going to chop it you pay up. Can you? Yeah, that's fine. There's no one here anyway, so. Okay, so this is our active quarry floor. We call this the North Quarry. Couple things to point out. You can see the vertical lines on the quarry face at specific intervals. Does anybody know what those are?
Blast holes.
Yeah, those are the blast marks. So it is an engineered design. We actually, when we blast, they'll do it in 2 rows, okay? And they go off like a set of dominoes, with the back row going first. So we have a separate third-party contractor that comes out here. They survey the rock face to look for any abnormalities in strength or in fracture or in bedding, and they engineer the design so that to ensure that obviously when we blow it up, they can predict where the fall is going to be. So it goes off like a set of really quick dominoes. When you watch a blast, it's actually quite neat. You see it, the rock lifts off the quarry face and then it falls down. And it falls in a remarkably neat little pile at the bottom if everything goes well. So obviously they do that. We have to be very diligent of that for safety reasons primarily, not just for environmental reasons like noise and dust. But I mean, obviously if you don't properly engineer a blast, you can have major problems if a rock comes flying out at someone, right? So when we do blast, we close off this whole area. We have people sitting at the roads that come into the quarry to ensure that no one comes into the quarry. We have a siren that goes off in the quarry and lets everyone know that a blast is going to happen, and then we do a countdown and the blast happens. It's a cool thing to watch. Anyways, also you can see these ponds that are around. So this is our sump is, I believe, over there in one of the ponds, but this is sort of representative of groundwater filling up the bottom of the quarry floor. We just pump it to a certain level so that it doesn't come on to our haul routes. If we stop pumping, then yeah, this would all fill up with water. Eventually, this whole area will fill up with water, and this will be a lake. That's what our rehabilitation plan is designed for this region. So you're sitting on the bottom of what will be a lake that people can come and walk around and fish in, and then a conservation land. So it's kind of cool. A little bit about the geology of the area. This rock, do you guys know what kind of rock it is? Limestone, right? Does anyone know the formation?
Sedimentary.
Yeah, it's sedimentary. It's called the Amabel Formation. This was deposited about 400 million years ago in the Devonian era. And this rock was actually formed from calcareous organisms. And the way that happened was 400 million years ago, most of southern Ontario was covered in a prehistoric sea. And the animals that lived in the water column that built their shells from the minerals in the water, that's what a calcareous organism is. Something like a modern day would be like a clam or a mollusk, secrete their shell from calcium carbonate in the water column. As those animals died and fell to the ground surface, as well as stemmed eukaryotes that are living on the ground surface died off, their shells were crushed, compacted, and they actually compose this rock. So this is made of like billions of tiny little fossils. Kind of interesting. So the overburden that we strip off of this area, you can see it sort of over here. It's piled up. So that's some of the overburden that we've taken off. We save all of that material. We don't ship it off site. The reason we save it is it's the best soil we can use in our rehab because it's native soil. So, you know, your teacher was pointing out the talus slopes over on the other side. That's progressive rehabilitation. We'll start sloping the area before we even get into tree planting and things like that. But native trees are going to grow best in native soil. So we save all of the soil and we use it to infill in our rehab plan. So that will be used at the end of the duration. And it works well both ways because it's the best soil to use and it means we don't have to pay to get rid of it. So it's great.
A couple questions. Number one, there'll be that tree row in between this body of water ultimately and the wet area on the other side. So that's part of the plan. And the next one is, I think this was it 10 years ago this opened up, North Quarry? Does that sound about right?
I think so.
So what you're looking is about approximately a decade of extraction.
So it's pretty significant.
Yeah, so it's a pretty big hole for 10 years, right?
I mean, one of the ideas that I hope you all leave with today is not only like the rehab and how we can be responsibly managing a quarry, but also the need and the significance of aggregate in Ontario and in fact to provide our quality of life. In Ontario, we use about 170 million tons of aggregate every year. If you put that down to per person, that works out to about 15 tons a year per person, right? And that's going into, you know, the obvious, like roads, like home foundations, like the bricks and the shingles on your home, sidewalks, hospitals, buildings, but also things you don't think of, like your toothpaste has aggregate in it. The ag lime that Melanie was talking about at the beginning that gets spread on farmer fields to correct the pH in their soil. So everything from your food to production, to the home, to your transportation, to our way of life requires aggregate. But obviously there is a huge impact. I mean, 10 years, this is a giant hole in the ground, right? It's a non-renewable resource. So the idea that my company struggles with, and that all aggregate companies are trying to get across the message is, it's a required resource for our way of life. So how are we going to manage it properly? And this is what we're showing you today, the types of solutions. So, I mean, I really want you to take a good look around you at this quarry floor, because I think when you see the rehab area that used to look just like this, it should sort of bring it full circle, and it should be, I don't know, it's impressive to me that we're, you know, like I'm in environmental compliance and environmental science and geology. So, I mean, I'm not involved as much with the extraction process as with the process of creating lakes and habitat, right? So that's what we're trying to do. We're just as much in the business of creating aggregate as in creating food chains. You'll notice that the ponds around here have that nice sort of Caribbean blue look to them. That's actually not a nice thing. It's total suspended solids that make it look like that, and that's from all the dust in this area. So we can't discharge that water. That would be representative of water that we would not discharge off site. So that would be pumped to the reservoir and then you know, naturally settle to the bottom, sort of thing. If a truck has an accident or falls over and spills into the quarry, or the reservoir, you can see these berms, and you can see over here that, so looking at this road, if we did have a fuel spill, it's very unlikely to run into that reservoir, right? That's sort of a mitigation for keeping all of the any contaminants sort of on this side. And if you look on this side of the bus, we're gonna come up pretty soon on our series of settling ponds. That's where all of the wash water goes to. So the total suspended, it's the closed loop system for washing the aggregate. The total suspended solids is settling to the bottom, and we clean that out about every year or as needed. We save the fine material and use it in rehabilitation. So it's just these ponds over here, and you can see that, again, that coral blue kind of color to them. That's the total suspended solids reflecting light back to the surface and changing the color. And they sort of wind and everything right back in there. And you can get a nice view of our talus slope that we're starting on this area. So that used to be a straight cliff face right to this quarry floor. All the resources have been expended in this portion. This used to be an active quarry. Well, it's an active processing area now.
So how long did it take to make this hole?
How long did it take to make this part of the hole? Since 70 whatever?
This quarry started in 19... You're making me bring out my sheet more than It's okay.
No, let's just
you need to know these things. You know, it's the 60s. It's
1964?
1962.
Started there.
It's when this quarry opened.
750 hectares.
Obviously, the first area that was extracted is now the rehab area.
And the average depth would be how many meters roughly?
The North Quarry that we just came from was at 315 meters above sea level, around there.
So it doesn't help me. How deep was the face? That was obviously higher than it is here.
Yeah, yeah.
So what was it?
I think it's about
40?
I think it's a little less than that. I think
30.
it's around 30.
Yeah, the truck's so bad. Up here.
No.
There's a panoramic view of the plant.
Yeah, it's a nice view of the quarry. I mentioned before, we started around 20 or 25 years ago. And the first thing we did, I mentioned that side of the road hasn't been touched. We looked at that side of the road and said, what's growing there? What can we be permitted to plant? Because you can only plant specific trees that the M&R approves. And how are we going to create a landscape that's representative of the surrounding landscape? Not only that, but we want to make a habitable ecosystem and a food chain for a variety of species. We want to enhance biodiversity potential on our site. So the way you do that is you create a variety of habitats. So What we have here is a wetland feature. We've created the talus sloping that I was talking about earlier on this side, which has grown up nicely, and we've left the cliff face there. We see a lot of turkey vultures and hawks that use that cliff for hunting. We get rodents that they like eating. A variety of duck species in the lake. We do see deer quite often. I was walking down there last week and I saw a series of deer tracks in this area. So we've created the variety of habitats as well. You can look at the shoreline of the wetland. It's meandering. It's not a straight shoreline. A lot went into making that look like a random feature, right? We have to, at the back, there's sort of a divide in the lake beyond that island. In the wetland, that divides the wetland from the lake. Not as much as a divide as a transition, but we want to create deep water for bigger fish, and we want to create shallow water for nesting habitats and spawning habitats. It's worked quite successfully. We do monitor the fish populations, and I had a question on the way up. We do not stock any fish. If you build it, Mother Nature will bring the animals there. They come in on the feet of birds, etc. In addition to that, we put an island in the middle of our wetland. That's for things like geese or migratory birds that want to build their nests in this area. You want to build it away from a shoreline so that animals can't come to destroy your nest and eat your young. So we want to encourage animals to have a sufficient food supply here to raise their young, and so on. We have a lot of tree planting events, and what we do at those is basically we might get a bunch of Girl Scouts or Boy Scouts in here, or other members of the public. M&R Rangers have helped us out a lot, and we get a variety of tree species that we're approved for, and they just kind of go nuts and plant them everywhere, and that creates sort of a random scattering of trees. We also use several varieties of grasses. So the big thing we're trying to do is create that variety of habitat and variety of land features. All features, deep features, you create a variety of habitat and you'll receive a variety of animals living here, which is going to create a strong ecosystem and create food chains in your ecosystem. I did have a meeting here last week with Conservation Holcim, and they're looking into, we're looking into probably giving them this parcel, and they'll probably have a hiking trail surrounding it for people to come and use, because the rehabilitation in this area is finished now. We're just letting things grow. We also don't fertilize any of the plants. We let it grow in the native soil. We have to have succession in mind, so when we begin the rehab, we have to plant fast-growing, short-lived species such as birch, poplar, and then they can grow in soil that might not have a lot of other nutrients in it. So we'll build up the soil, we'll plant the fast-growing species, and then hopefully succession will take place to put in the longer-lived species. We do see some maples that are coming up on this side of the slope. That's sort of some of the older, where we began the rehab. And yeah, so it's actually working very successfully, and this is it's definitely a site that Dufferin and Holcim are extremely proud of in what they've created here. So I mean, if I didn't tell you, and be honest, if I hadn't told you that this was an active quarry and you came upon this on a nature hike and there wasn't a sign there saying it was once a quarry, I mean, would you immediately know that this used to be, or that this was man-made? No. And that's what we're trying to achieve. And the animals don't know it either, because we do get quite a bit here. We see heron here, all kinds of rodents, obviously like squirrels, raccoons, stuff like that. We did have a peregrine falcon here a couple weeks ago. So we're getting even some of the rare species that you don't see every day, we're getting in this area. So we think of it as pretty successful, and we want to continue that success throughout the quarry. So what you saw today, when I'm like an elderly person, I hope to come here one day and go for a nature hike, and it'll all look like this. You know, there's not going to be any sort of man-made impact features. We don't control bringing animals in or anything like that. We just focus on creating the type of habitat that we know they like.
What's the education level of most of your employees?
or co-workers?
It varies, and I asked this. I actually asked this question of our CEO, asking him because I was thinking about doing my master's, and you know, we do have incentive programs and stuff like that, whereas sometimes the company will help you out to do your master's if they think the program you're taking is something that's beneficial to them or to get your degrees. But it really varies across the board. There's people in the company I know that are higher up than me that have college similar to yourselves, but a lot of experience in the field. And there's people that are lower than me that have a master's degree. So it's really, my CEO's answer was he really doesn't care. He just cares what you can produce when you get into the job. But definitely, like in my experience, the level of education is going to help you get your foot in the door. But even if you have a master's degree, if you can't produce results, then they're not going to care about your degree. So cement is just powdered limestone. If you looked at it, concrete is the final product we make from cement. So concrete is aggregate sand and stone mixed with water and cement to produce the things like sidewalks and foundations and all that.
Thank you very much.
Oh, thanks.
Wonderful tour.
This will never give me a present. Thanks a lot, guys. You were probably the best group I've had this year with interest.
I only brought the smart ones.
So it's really a treat to give a talk of the quarry to people who are actively involved in conversation and interested in what's going on. So I hope you learned a lot, and thank you very much.
Thanks,
Very much,
Jessica.
Jessica. Take care.
Yeah, you too.
Sweetheart.
My present.
What's your present? Your present. You already get presents when you attend a lab.